Hi, hello everyone. So, in order to use your Jasper Gold tool, we need to write assertion, something like this. So, what is assertion? How to write assertion? How to visualize these kind of waveforms after writing assertion in Jasper Gold is the main topic today. So, in order to write these assertion, we need to know what is assertion and why it is useful. Let's go here. So for example, let's say I have three signals, signal A, signal B and signal C. I am expecting once a signal A becomes high, in the next clock cycle signal B should be high, and if signal B becomes high, in the next clock cycle signal C should become high. If you see here, these first three cases will fail because our assertion doesn't know anything about signal A or B or C until this three cycle. But in the fourth cycle, whatever the case we are expecting is happening. Here you can see in the clock cycle 2 A becomes high, and in the clock cycle 3 B becomes high, and in the clock cycle C, in this fourth cycle C becomes high. So this will be a pass, and even in the fifth the same way it is passing. So in order to understand or analyze or test this, we need to write property, and also we can test it very easily using assertion. So these three things will not create a fail. This will also pass, but this will be called as Wacker's pass, which I will explain you later what is called Wacker's pass. Let's go into this material which I found in online, and this is really a good one. I am attaching the link below for you to refer this. So basically, as I explained you earlier, here also they gave two simple examples which you can see, where every time rec goes high, arc arrives exactly 3 clock cycles later. So we are writing assert property at passage clock when a rec is high. Here in the system Verilog constraint, whenever you are just writing a word rec, which is mean rec is equal to 1 tick d1. So when rec is high, which implies this operator is called implication operator. Whenever it will, what it is purpose is like whenever the left side of the implication operator becomes true, then it will check the right side of it. So here you can observe that this left side becomes true. In case if the left side becomes true, then it will check from that 3 clock cycle whether arc is true or not. And we have another one example where here they are telling check if count increments every time valid is set. So whenever a valid is set, it needs to check whether the count is incrementing or not. So how can we do that? Here in this assertion there is one function called dollar $passed. There are many inbuilt function like count once, dollar $passed, and then there are few other things also. I'm not going through every of this thing in this class. This class scope is not that. I just want to give you a brief introduction about what is assertion so that you can prepare by yourself. And also I'm attaching sufficient material for you below. But the main focus of this course will be like going towards Jasper Gold, and exploring the verification area. In case if you feel like you want more clear explanation or more examples for this system verilog assertion, put a comment down, I'll be making one. So here they are setting like count whether is equal to dollar past of count plus 1. So here the present count and the past count plus 1 is equal or not, we are checking. That way we can prove this assertion also. So this is a simple way to write assertion. So basically there is two types of assertion. One is called immediate assertion and the other is called concurrent assertion. Immediate assertion is nothing but like a if else condition, where here we will be writing assert if current state is not equal to 0, then assert it. It won't fail. If not, it will throw an error that checker fail, like that it will say. And here there is another example for concurrent assertion. There is two format to write concurrent assertion. I prefer always the second format. Though I prefer the second format, I'll just explain you the first format too. So the first format is like you can give the name and then you need to write assert property, and whatever the if you want to say like at passage of the clock, then you will say at passage of the clock. I am telling here, if reset is there, then disable this entire assertion so it won't go beyond. If this condition satisfies, then it will come here, it will check the implication operator. Before the implication operator says rec, so if rec is high, then it will go and check after the implication operator. Here we are telling after 3 clock cycle grant should be high, like that we are telling. In case if it passes, it will pass, if not it will give you an error. This is one format. The other format is like you need to give the property name and then your property name. You need to give this at passage of the clock or disable if reset, the same like the above one. And then I am also here also writing the same like condition like that, and I will end the property. So where I will use this property means I will write the below assertion name, what assertion name I am going to use it, and then assert property, and then I will give this concurrent property name, whatever the property name it is, I will give here. So this is the second variety of writing it. I always prefer this variety, writing this way. I feel this is much cleaner than the other ways. And immediate assertion cannot be used in everywhere. Like in case if you want to create a sequence or something which we are creating here, you can't use the immediate assertion. So try using property like concurrent assertion, which is better practice to use also. So other than this, if you see here, there is two operator. One is called a overlapping operator and non-overlapping operator. So this overlapping operator, when you will use means, in case if I want to check on the same clock cycle, I will use this operator. In case if I want to check in the next clock cycle means, I will use this non-overlapping implication operator. These are the two operators which you need to know about. And then as I told you, dollar paused we just saw, and there is something called dollar rose, dollar fell, dollar stable. So dollar rose is like, for example, let's say here I am able to see this valid signal is going high, so I can use like dollar, when dollar rose of valid, then data should change, or data, what is the data, capture the data, like that we can write. So dollar rose is for going up, when a signal goes up it will take that instance. Dollar fell will be useful for capturing the signal falling down, this instance. And also there is an option called dollar stable. So there can be condition like where when my rec is coming, my act should not go low, like that if it is happening means, or until my rec when my rec is given, my data should not change, something like that if it is there means, then we can use this dollar stable where when rec is high, then which implies my dollar stable of data, like that we can use. For that it will be using. And count ones is for counting the number of ones you have, and then one hot number is for generating the one hot number. So these are the few things which we will be using often. These operators, we might not use this and or and all we will be using, and then this is just these things. But delay operators, we won't use larger delay in formal verification, because formal will try to create multiple combinations of it, and these operators, these below two operators, many time we won't use. These are all the things which you need to know when you are coming into formal verification. Try reading through these examples, which will be helpful for you, and that will be all. I thought of showing you one or two example here. So how I am writing the formal verification code, you can see here. So how I will be writing is, as I told you, I write in the second way of property based verification, in the concurrent based verification. So I'll be just giving property A causes B, something like that. Here I took a very simple FSM of 1010, something like that, where the state will be changes from sequence detector I'm using. So for that I'm trying to verify that. So this is a simple verification which I am trying to do. And once if you want to run, you can run here. It will run. In order to prove this thing, if you want to prove all these things, you can click prove task, or if you want to prove just one, you can click prove property. If you want to click prove all, you can use prove task. So that's all. This is how you need to write assertion, and use that inside your like design file or tb file, anything whichever you have in your in your formal tool. I hope this video will be helpful. Let's meet in the next video. Thank you.